have been discussing with phasor analysis of electrical circuit. Essentially, any circuit with energy storing elements will have a natural response and solution due to forcing function. If the solution due to natural response will decay down to 0 very quickly, and people are mostly interested to find out the solution due to steady state currents. If that be the case, then we have found for an RL circuit the supply voltage is equal to some V max sin omega t, and the current of the RL circuit we have seen it is equal to V m by Z some sin omega t minus theta, and this is steady state current. Okay. This is we are interested in steady state current only. Then what I am telling is this, that this voltage if it is, but they must be varying sinusoidally, otherwise not. Phasor analysis of electrical circuit, when excitation is sinusoidal, when excitation or forcing function, excitation or forcing function, then only you can do it. Forcing function is sinusoidal. So, if VST is this, then I told that okay, then this Vs can be represented as a phasor moving with a speed omega, and your current phasors will be can be represented as I bar, and it will lag this by an angle theta. And suppose this is the reference phasor you have drawn, then in general this plane, and both of them are moving with omega, so that is fine. So, at any arbitrary position if they move that is this is at t equal to 0 I have drawn the position of the phasors, but relative positions of the phasor is independent of time, that is at omega t the situation will be like this. Position of the voltage phasors will advance Vs, and your current will come here, but the angle between them is theta, and this is omega t, is not? This angle is omega t, because Vs at t equal to 0 it was horizontal. So, it has moved by omega t. I has also moved by omega t, that is why the angle between them is constant from this to omega t. So, earlier I was, when V was here, I was here. So, this has also moved by omega t, and it is there. But anyway, so I will always draw the phasor diagram in this way, that is at omega t equal to 0, Vs is occupying the reference, and then I can say, if I think that it is a complex plane, so I will say Vs bar the angle this is suppose the real axis and this is imaginary axis, then I will say Vs bar is only having real part. So, Vs plus J 0, is not? You draw it in this way also, you can write Vs bar will be I mean theta plus omega t, whatever you do, but in this way I will just write Vs bar, and then I will say that Is bar will have, that is no imaginary component present in Vs bar. I bar on the other hand has got a real part whose magnitude will be this length into cosine theta, and if you break it up into two components, I cosine theta minus j I sin theta, I sin theta. So, in polar form this will be V s into e to the power j 0, and this current in polar form will be e to the power minus j theta. At omega t equal to 0 I am writing. So, this is the voltage and current phasor. This one, instead of writing e to the power j 0 always, people write it like this, angle 0. It means that it is V s into e to the power j 0. Similarly, this one people will write I minus theta, like that. Got the point? Therefore, your supply voltage, see everything is real here, but now I am, somebody suggested, not somebody, I should say Steinmetz for the first time told that okay, to get the solution due to forcing function, you do not have even to write the differential equation. Do it like this, because excitation is sinusoidal. So, forcing function solution in the steady state will be also sinusoidal of same frequency. If that be the case, then you can represent them in phasor in this fashion. Of course, these two results were obtained classically. Then he is suggesting something very interesting. So, he tells that represent VST in terms of phasors, phasor. The current in terms of phasor like this. Now, the argument is like this. Okay, just out of curiosity, what you do, you divide these two phasors V s bar by I s. I must draw the circuit so that you do not be misunderstanding me. This is the supply voltage time V s t, and this is the current I t. So, why I have written I s t? It is not, it is the current in the circuit I. Now, this I will just divide. What is the value of this V s? It is the magnitude V m 0 degree. What is the value of this current I? It is, this is I, and this is I am writing as the magnitude of the phasor. Magnitude of the phasors are the peak values V m by Z. Now, therefore, what I will do is this can be written as its magnitude, an angle 0, divided by magnitude of the current, that is I, this is suppose I m with maximum value I am in. So, I m divided minus theta, and this I know is nothing but V m e to the power j 0 divided by I m e to the power minus j theta. If you divide these two, it will come out to be V m by I m, magnitude divided, and angle gets subtracted, e to the power j minus theta. It will be just like this, minus plus 0 minus theta plus. Now, what is V m by I m? I m is equal to V m by Z. Therefore, V m by I m is equal to Z. So, this quantity is Z into e to the power j theta. This is the thing. Recall that this Z, I will write it with different color. This Z we established, it is nothing but r square plus omega square L square. And what is tan theta? Tan theta was r by omega L, is not? This we decided. Then you get this j into e to the power z theta, which is z cos theta plus j z sin theta. And then this z cos theta, you see this tan theta is r by omega L. So, if you consider a right angle triangle, z cos theta, tan theta is known, so cos theta is known. How much it will be? It will be z cos theta, I am so sorry, this I wrote wrongly, omega L by r, tan theta is omega L by r. So, what will be cos theta? Cos theta is r by root over r square plus omega square L square, which is equal to r by z, and sin theta is equal to omega L divided by root over r square plus omega square L square, which is equal to omega L by z. This will be the thing. Therefore, z cos theta is nothing but r, and z sin theta is equal to omega L. So, these two things gives you r is equal to z cos theta and omega L is equal to z sin theta. So, I just put that j omega L. So, what I told you, just I represented sinusoidal quantities in phasors. The angle between phasors do not change, that is comes out to be theta, and then I could represent the supply voltage as a phasor as V m 0 degree, peak value 0 degree, current value I m, it will lag the supply voltage in case of this minus theta. You divide these two and you get this thing. Ratio of V s by I s phasors, and this is what? This is the ratio of V s phasor by I s phasor. And these things turns out to be a constant of the circuit. For a, it depends on supply frequency, that is there, but no supply voltage this that. So, this ratio is constant. And how did I establish that? I did all the hard work to get the solve the differential equations, got the steady state voltage and steady state current. Then I am told that only steady state currents we are interested in. And then I thought, okay, both are of same frequency and sinusoidally varying. Therefore, they can be expressed as some lengths whose values are peak values, V m and I m, and this is I m. And then I represented it in complex plane as V s 0 degree and V m I m minus theta. Then I am telling let us see whether these two phasors have some relations. See, in case of DC circuit, V by I is equal to R. That is what we are always applying. Now, when it comes to AC circuit, then I find that the ratio of the phasors, not of the instantaneous quantities, not VST by IST, you cannot proceed further, because sin omega t by sin omega t minus theta, that will be also a function of time. It has got no meaning. I mean, no meaning means it does not help me in any way. But we find that if you represent them in phasors, then take the ratio of the phasors, voltage phasors, divided by current phasors. If you do, then a surprise thing happens. We discovered that the ratio is a constant complex number, whose value depends on the circuit parameters R and L. Of course, not L alone, supply frequency, if it is omega, it is to be multiplied by omega, that I can always do, and this ratio is constant. So, the thing is, the current phasors in the circuit will be equal to V s bar by Z complex number. This is called Z bar, having real and imaginary part. So, to summarize, this point is important, that here is a circuit R, L, here is your supply voltage VST. In time domain, this is the circuit VST is equal to some Vm sin omega t, and the current will be also real. Why things will be imaginary? No imaginary thing in real life situations. Applied sinusoidal voltage, you will get some current. The value of this current is Im sin omega t minus theta, and this was shown to be Vm by Zm. Z, what is Z? Root over R square plus omega square L square sin omega t minus theta. This is all done, but now I am telling that this circuit, you imagine it is like this R, and here you write some j omega L and represent the variables as phasors. So, supply voltage is Vm angle 0 degree, and then the current I bar, you show it like this. Then we showed that Vs bar is equal to I bar into Z bar. Therefore, if I knew this earlier, that forcing function maintains such a beautiful relationship similar to that of a DC circuit, V is equal to IR, nothing is better than that. What you will simply do is this supply voltage sinusoidal time varying term, remove that time terms represented by a length Vs. Then the resultant current too will be a phasor I bar, and it will lag the supply. This is omega, this is also omega moving. So, current will lag by this, and if you know the supply voltage, then our problem is to find out the current. After establishing this, I will tell henceforth I will represent the supply voltage as Vm0. I will find out Z bar like this, I will find out and say that my current in the circuit will be Vs bar by Z bar. What is Vs bar? Vm angle 0 degree. What is Z bar? Z bar will be z angle theta, z e to the power j theta it means, and if you divide these two you will get V m by z minus theta. So, I have solved for phasor current, Of course, I will be interested to know how current varies with time, then I will say if this is the phasor representation, I t will be V m by z sine of omega t minus theta. Got the point? That is, you do your calculation is phasor domain, get the current phasor, find out the impedance of the circuit z bar is equal to r plus j omega l. It is a complex number. This is not a phasor, it is neither rotating, nothing like that, but the ratio of the voltage and current phasor comes out to be a complex number. And so, z bar, I will be always using bar over it, its magnitude is z and angle is theta. And we have shown in my last slide, this is nothing but z sin theta, z cos theta is r plus jx omega l. Omega l is often called reactance of the circuit and written like XL, inductive reactance. So, this is a very important and crucial step. That is, here is another alternative way of getting the solution due to forcing function. You do not have to write down the differential equation anymore. It is, those days are over. After knowing this, the voltage phasor and current phasor, this ratio is a constant complex number decided by the circuit parameters. If that be the case, if I knew this, I would have, if I knew this relationship, I should now do like this. Supply voltage is known, Z bar is known, get I bar, and I will get this current in phasor form. But switching from phasor to time domain does not take any time. Just looking at it, I will write okay sin omega t minus theta. Got the point? Therefore, circuits with AC excitations, and if you are only interested in phasor sum, I mean steady state currents, then nothing is better than this phasor analysis. Supply voltage is there, represent it in phasor form. Circuit parameters are known, write Z bar. Your steps will be supply voltage phasor, then write Z bar, then get I bar, then get I bar, then IT, time domain expression of the current. That is the thing. See, it has got a tremendous, now I am going to make a very big statement. Now, in case of DC circuit, I told you this is the battery and this is the current and this is R, and we know that E is equal to IR. We have seen that. Now, in AC circuit, there will be some impedance Z bar, and here is some supply voltage which is phasor. I will put a bar always to indicate phasors, and this current I bar, it is same just like this. No differential equation writing, no, plus minus. If that be the case, then I can invoke all the things I have learned with the AC circuit, DC circuits, that is, two resistances are connected in parallel. Equivalent resistance is R 1 R 2 by R 1 plus R 2. How did I derive this? Based on this only, wrote some KVL, KCL equations here, got this current. For example, if the total current is I bar, I, what is the current in I 1? Current in I 1 will be I into R 2 by R 1 plus R 2. All these things happened because E equal to I R. Similarly, here only thing is, okay, these are not some real numbers, you have to deal with complex number, but nonetheless V s equal to Z bar into I bar means that if two impedances are connected in series, this is Z 1 bar, this is Z 2 bar, this is V s bar. Current in this circuit will be I bar is equal to V s bar divided by Z 1 plus Z 2. This will be the current. If the impedances are in parallel, but this time you have to show with a bar. In phasor domain, we will calculate everything. Here also Z equivalent will be equal to Z 1 bar, Z 2 bar, same relationships, Z 1 bar plus Z 2 bar. Similarly, current in this branch I 1 bar, all are phasors, will be equal to total current I bar into Z 2 bar divided by Z 1 plus Z 2 bar. See, the power of the phasor notations lies here, that immediately you get V s equal to Z into I. Here is there any time terms? No, only complex numbers. Once you get that, then all the rules of impedance manipulation, resistance manipulations, current divisions, similarly KVL here V s bar, as you can see, minus 2 plus V s bar, plus to minus I bar Z bar, that is what? V s bar is equal to minus Z bar I bar is equal to 0. So, KVL equation, KCL equations at the junctions in terms of phasors will all be valid. Anyway, we will continue with this in the next class, but you see, try to understand the flow of logic that brings us to phasor notations. Okay? Whether a relationship V is equal to I R in DC circuit, it was so obvious and everything is constant here. Similarly, there exists similar relationship in AC circuits, but only thing, these are not time domain equations, these are all expressed in phasors, and if you know phasor representation of any of the quantities, voltage or current, writing down the time domain expression should not take any time at all, provided you know where your reference phasor is. Anyway, we will continue with this in the next class. Thank you.